For RCR Wireless News, my name's Sean Kinney. We're here in the Qualcomm booth, and Yongmin, you just showed us a very interesting demo about coordinated multi-point spectrum sharing for 5G NRU. But before we talk a little bit more about that, I wanted to look back first. You know, as LTE developed, it wasn't until quite late in that cycle that we saw LTE unlicensed and then LAA, which was really a key development. So now that we already have these work items in front of 3GPP related to 5G NRU, how do you think that portends the development of 5G NR for unlicensed as compared to what we saw with LTE?
Yeah, that's a very great question. So when we, in LTE days, when we started NR LTE unlicensed, and we started working on the LAA in release 13. So ELAA will be release 14. Now, obviously, through that process, we learn a lot of things. And over the years, we already see some deployment from operators in the North America and other regions. So all the things we learn over a year become an experience for us. We can build into the 5G unlicensed. We can really optimize the system even from very beginning for the unlicensed use.
So right now, 3GPP has two study item open for 5G NRU, looking at it 5 gigahertz and 6 gigahertz. So how do we move from these study items to seeing that put into the next release and then into deployments like what you explained?
As part of release 15, there was a study item to look into how do we employ, NR unlicensed in the early days, right? So we did an extensive study of study item as part of release 15. And that study item now got officially approved as work item, part of release 16 last September. And that spec is expected to finish by early next year, Q1 or Q2 next year. Today we are showing our latest demo about spectrum sharing using 5G. This year we actually was able to make it work using our commercial silicon and our mobile testing platform in almost in the form factor of smartphones. Here's what it looks like of our device. So in this second setup of the demo, we're going to try the example with two networks. So what happened is the same setup, but we mimic a situation where you have two basically service providers in the same location using the same spectrum. There's a wall in between to indicate the separation of the two networks, right? Still the same setup. 4 base stations, but now we have 2 base stations on one side and 2 base stations on the other side. Obviously, the first step we're trying to show is so-called uncoordinated sharing. What it means is whenever I transmit from base station to my terminal, I have to listen to other links. If other links are using the channel, I cannot use the channel. You do notice that even for the links of the same network, they kind of taking turns, they block each other. But that is not necessary because, for the nodes within the same network, they actually understand each other. They actually going through the same network. So we actually can do better than the uncoordinated sharing. So that's a step of the TDM CoMP. It's basically time division multiplexing using CoMP. So what you're going to say is now the different links, different base stations of the same network, they kind of talk to each other. They can jointly transmit into their own devices. They can beamform into them. They don't need to block each other. The duty cycle becomes 50% and the throughput gain becomes twice. So the next step of our demo is spatial domain multiplexing CoMP. So in these scenarios, we no longer have to disallow the other side of transmission. Now the two networks can be transmitting at the same time, 100% of duty cycle. Now the throughput gain is like 3 times. Because of the increase of the duty cycle. Now you might be asking why it's not 4 times, because what happened is in this kind of setup, because of 2 networks, we have limited coordination, meaning we don't exchange data, unlike the coordination with the same network or the base station exchange data between them. Now in the SDM case, because of 2 networks, they don't share data because of privacy, because of business reason, they cannot share data. In this case, we only listen to the over-the-air signal to figure out when I transmit to my own devices, how do I tune my transmission so that I don't create interference to the other side. This is called spatial non-link. Because we're doing spatial non-link and we are doing limited coordination between 2 networks, so we say 3 times gain, because we leave a certain space for beam non-link. The NR unlicensed is already part of release 16. The spec will be finalized next year. So in the coming years, we're going to say this kind of technology to be materialized for all kind of use cases like enterprise, say private network, industry IoT. We're looking forward that day to come.
And so for, if we consider a hypothetical deployment where it's a warehousing facility, this gives the owner of that network or the operator a lot of flexibility in how they can use that spectrum in a shared way or in an unlicensed way, right?
Oh, absolutely. So, I just take one example. For example, in Germany, the regulator just opened up 3.7 to 3.8 gigahertz as a spectrum for industry IoT. And there, the current framework is different manufacturer owners can operate in the same frequency band. They may be next to each other. In such a case, you can imagine how do they share the spectrum efficiently. I think this kind of technology will fit perfectly well in those kind of applications. And in the US, we are also working with regulators and other partners in the ecosystem to explore the option of how to use shared unlicensed spectrum to deploy localized service for 5G.
Then I was hoping you could tell us a little bit more about the time synchronization component of this and what that means if you're trying to have multiple operators working simultaneously in the same area.
Obviously for TDD band, if you have different operators in the same areas, even for adjacent channel, you probably need time synchronization. Otherwise, you run into downlink, uplink kind of interference issues. So all these things kind of come just in time for us to encourage the time synchronization between different operators as part of the NR unlicensed.
So expect to hear a lot more about 5G NRU for the foreseeable future then?
Absolutely. Release 16 is one of the major features already, and we will continue to work in Release 17.
Okay, well, thank you very much for giving us an update on 5G NRU, Yongbin.
All right, thank you.